Whether we like it or not, computers seem to be taking over our world. New uses are being found almost daily for these machines, virtually dependent upon them. Under the circumstances, many of us have from time to time found ourselves faced with a sort of intellectual dilemma. It is only natural for us to be curious about what a computer is and just how it works. On the other hand, however, most of us just don't have sufficient technical knowledge to understand the very complicated explanations that have usually been offered. Well, a few weeks ago, a new teaching device came on the market, and we have it here this morning. It's called the Minivac 601 computer. Technically, it is not a computer. You'd have to call it a computer simulator. It's a device intended to teach people in schools and other places how computers operate. Since I am eager to show off my newly acquired knowledge, I must confess in the last 24 hours, having just learned how to make it work, I'm going to see if I can pass some of this information, which is fascinating, on to you. Now, this is one of the Minivac 601s we have with us today, and I'm going to turn it on, and it's doing essentially the same thing that we've seen the pictures of computers doing, clicking and flashing and carrying on and being kind of mysterious. Now let me quiet it down just for a moment. Well, I'll get it. There. See? And I'll give you some explanation. Now, all the commotion you saw a moment ago was the Minivac's or any computer's way of counting. And that's all it was doing, just counting. And you have to bear in mind that there are two basic types of computers, digital and analog. This device is a digital. And a digital computer is basically capable of two primary functions, and that's all. No matter how it can add and subtract, and that's it. No matter how complicated a problem can be, it can be solved by addition or subtraction, provided you're willing to take often a very long time. After all, multiplication, division, and these other things are simply shortcuts. And since computers work so quickly, they don't need these other methods. So, to understand a computer, we must first of all understand how it counts. And since computers have neither fingers nor toes, as some of us use to do this on, they have only switches that either signal on or signal off, then a special system of counting has to be used. So, we will try this now. As I press this button down here, the machine, I hope, will count 1. It did. Now, all that happened was that a relay was switched on and a light lit on the machine. But in effect, the machine is remembering a number 1. Now, if I add another 1 to this figure, this is what happens. It remembers 2. One relay went off, the other went on, and 1 and 1 does make 2. But if I add another 1 to this total, it gets a little more complicated. The machine is now remembering 3. 2 and 1 are 3. That's the extent of my technical knowledge. And this, in its simplest sense, is how all digital computers count, by turning on a series of relays, on or off, until the final answer is reached. Of course, in practice, nobody is going to stand around punching a button as I've done for some of the big figures we have to use. Engineers had to find a much faster way of feeding numbers into a computer. Remember those cards you get in the mail sometimes? They say don't twist them or spindle them. Well, they are punch cards, and they're one way of getting numbers into a computer. At times, punch tape is used, and at other times, a dial, something like this, is used. First, I clear the machine, and I'm going to set this to 15. And I'm going to turn it on. Look at that. It's the wrong switch. Well, I knew that was going to happen sometime during this. I'm going to turn it to 15 again. Believe me. And press that button. Is that the right one? That's the right one. The machine has counted up to 15. 8 and 4 is 12, 2 is 14, and 1 is 15. Now, if we want to add 9 to that, and I've fouled this all up again. Let's make it 15. And then let's add 9 to that. And I did it. 16 and 8 is 24. 15 and 9 is 24. And having survived that, I think I'll go on to the other machine. Now, this machine over here is set up in another way. I can show you that this has been programmed ahead of time, and these little wires here have set up a problem in the machine. In other words, it is set now to answer some questions we're going to give it. The reason for the second machine is that we could have set up the first machine this way. There are various types of computer circuitry, but all you really have to do is move these wires around, and we've saved this much time. Now, we've had the machine set up in advance, and before I show you the more conventional, it's called a readout method that I had mentioned, I'd like to branch off to this other computer function. So far, we've been discussing only mathematics, and as all of you know, computers can solve problems of logic. Now, bear in mind, however, that mathematics and logic are very closely related, and to use a computer for a logical problem, all you do is assign a value or a number to each bit of information in the logical problem, and the computer actually works the problem out according to the rules of logic. And therefore, we have set up this machine now. I'm going to turn it on, and it's going to solve a problem for us that would take us a very long time otherwise, and that I would never be able to do on my own. I'm going to call on my colleagues Frank Blair and Helen O'Connell to help us in this.
Oh, so Casey became a grandfather.
That's right. Good morning, class. How am I doing?
You're doing beautifully.
Well, okay. I hope you're getting this, because it is kind of interesting. Frank,
it's kind of interesting.
The first thing that we want to do, I'd like you to think of a number from 1 to 7, and tell me if the number you're thinking of is odd or even.
Let's have Helen do that. All right, Helen?
It's odd.
All right, the number's odd. That's the first question that the machine has asked in this. And so we turn this little switch, yes, the number's odd. The next thing is, if you divide by 4 the number you are thinking of, tell me if the remainder is greater than 1.
No.
Okay. Now, finally, is the number that you are thinking of greater than 3?
Yes.
All right. Everybody ready?
Yep.
I'm not sure.
I'm not sure either, but we're going to try it. The number is 5?
Yes.
I like that. I ought to applaud the machine.
I know it because we agreed on it before we came over, see?
What was going on in the mind of this machine, and it's a kind of a simple mind, but it's more sophisticated than mine at this point, is that we had, this is a schematic of the various questions the machine asked. It asked one number, and then it could be one or the other, and it turned out to be this, I think, yeah, 5. It asked the second question, and it turned out to be over here, and it asked a third question, and finally worked it down logically, asking only 3 questions, and found out the number you were all thinking of.
Can this thing read teleprompter?
Yeah, it could. I imagine they could get it set up.
Oh, boy, then we're all in trouble.
Well, this is the heart of the things that make many decisions. In other words, they tell a machine like this, a great big one and a very sophisticated one, that if various things happen, it has to react in a certain way, and it goes an awful lot faster than we do.
Like the machine figured out all those averages and things we needed for the Maris and
That's
Mavel.
right. Did you see any of those? It was astonishing.
What? I didn't hear what you said.
Well, when Maris, in baseball.
Yes. Oh, yes.
Frank,
Yes, I saw that every morning.
And the computer told us
Exactly.
terribly accurately.
What chances they had, the odds. That's right.
Frank could have figured it out. At least we all believe that Frank could have.
Yes, I think we believe that.
But
we're all fools, aren't we?
He would have figured it out in time for the 1984 World Series.
That's right, John.
Well, that's really the value of a computer. It isn't any smarter than we are, but it's a heck of a lot faster if you set it up in advance. And our lives are determined by them. You remember that they're yelling about spending in the Pentagon, and a lot of money is spent by machines that automatically punch out the checks? And the inevitable story came up last week of some firm that was supposed to get a $40,000 order, or it was supposed to buy 40,000 things, and it ended up buying 111,040 things.
They do make mistakes.
Oh, we depend on them, sure, and they make mistakes.
I'm going to argue with my creditors.
You know, you could really mess up the economy of the United States if every one of these cards you receive that has these punch holes, if you just
punched another hole. Haven't you always wanted to do that?
Oh, I've got an idea.
Temptation to bend them.
Paul Reimer, who used to write a radio program called Vic and Sade, had a lot of mail. And sometimes people who were a little odd in the head would send him things. One woman used to send him $1 million check about every couple of months. Paul Reimer would just endorse it and send it right onto the bank, and the bank would go mad.
Why don't you say goodnight, Gracie?
That's right. This is Rush. I'll let him say goodnight for it.
Bye for now. Station break.
The Joey Bishop Show, tonight at 8:30, 7:30 Central Time on NBC.